So we want to look at binary operation. Okay. When is an operation said to be binary? So what is a binary operation? So let's note it by star. So say star is a binary operation in a set A if for all A and B in A we have that A star B is an element of A. So we only say star is a binary operation. This operation star is binary in the set A if for all A and B elements of A, we have A star B an element of A. So if A star B is a subset or is an element in A, is a member of A, then star is a binary operation in A. And so star is not a binary operation in A if when you act A star B, we get an element outside A. So let's see an example. So if A is a set -2, -1, 0, 1, 2, then A star B is defined as A plus 2B. So let's see. Is star a binary operation on A? So let's pick two numbers from A at random. So we have -2 star -1. This is going to be -2 plus 2 -1, which is -2 plus -2, which is -4. And -4 is not an element of A. Hence, star is not a binary operation in A. So it fails to be a binary operation in A. But if you extend the set, okay, suppose we say A is R, okay, is a real set. So you say A star B is equal to A plus 2B. Then of course this is a binary operation because n2 elements that we add, if A and B, so here the assumption is that A and B are in A, meaning that they are real numbers, okay? So n2 real numbers, A is a real number, 2 is a real number, B is a real number. So the product of 2 and B is a real number. So when I say A plus 2B, the sum of two real numbers is a real number. So we'll say star is binary in R. And R in this case is just A. So star is binary in A. So once I add two elements of a certain set and I get an element in the same set, then I know that the operation that I'm using to add those two elements is a binary operation in that set. So what other thing do we need to know? When is the same binary operation said to be commutative? Okay, so we say star is commutative if whenever we have A star B, we get the same thing as B star A. So you can swap them. You start with A star B, you can swap them to B star A. Okay, so let's see an example. Is star commutative in Z? Given A star B is equal to A minus B squared minus 3ab. So is star commutative? So the solution, so we say star is commutative if A star B is equal to B star A. Now A star B is already given here. So our target is to get B star A and show that it is equal to A star B because we know what A star B is. Okay, so let's see how B star A looks like. So B star A, where there's A there, we're now starting with B. Where there's B, we have A squared minus 3BA. Now these two integers, you're dealing with integers A and B, and you multiply them, you get the same value even if you switch them. So multiplication is commutative even in integers. So we are going to have B minus A squared minus 3AB, since A, B are positive integers. So it's just the same thing. Okay. Then inside here, we can factor out a negative and have negative B plus A, but put this whole thing in the brackets, minus 3AB. Now, if I have AB to the power M, lots of indices allow me to distribute the power like that. So I'll do the same. This negative here has a 1, so I'll give it a 1 and square it. And then inside here, I can rearrange them and then square, then I have this. So what we have now is that negative 1 squared is just positive 1. So we have A minus B squared minus 3AB. So let's look at A star B. So A star B is exactly what we have here. Remember we started with what? We started with B star A. So now B star A is equal to A star B, hence star is commutative on this. So star is commutative. So commutativity is just being able to switch. So if you have A star B, you don't care even if you stayed with B and have A the other side, you don't care. So you're saying A star B is equal to B star A. The order doesn't matter, then it is commutative. But if the order matters, then it's not commutative, okay? So when you're showing that it is commutative, you don't pick an example. If you are disproving, then you can pick a specific example, because if one fails, then everything else, you don't care even if they all work. For the particular one, the one that fails, it allows you to say it's not binary. I mean, it's not commutative in general. It works, yes, for others, but for a specific example, it fails. So you cannot say it's binary. I mean, it's commutative in general, unless you exclude those numbers that makes it fail. Okay, so in that set, it has exceptions. So let's see an example where it fails to be commutative. So we have A star B is equal to a B minus A. Can I say plus 3? Okay. Now, is this commutative on R? Let's see. Is this commutative on R? So we know that commutativity implies A star B should be B star A. Now A star B is known, we have it there. So let's pick a B star A. So B star A is going to be A minus B plus 3. Okay? So is this the same as B minus A plus 3? So the other way of checking if it's the same is to subtract. Okay? Since we have A star B there, if we subtract B star A, if these two are the same, then when you subtract, you must get 0. Remember, if you have 2 you subtract 2, you get 0. If you have 3, you subtract 3, you get 0 because these are real numbers. So there's no magic there. If I have the same number and I subtract it from itself, I'll get 0. So if these are the same, then you must get 0. So let's see. A star B is B minus A plus 3 minus B star A is A minus B plus 3. So what do we get? We get B minus A plus 3 minus A plus B minus 3. So what do we get? The 3 will cancel. Then we have B plus B, which is 2B, negative A, which is negative 2A, and this is 2B minus A, which is not equal to 0. Okay? For as long as B is not equal to A, we won't get 0 here. And we haven't been told that A and B are the same. So, what are you going to say? So say hence, star is not commutative on R. So I found a situation where it fails to be commutative. So you must be able to know, you must be able to show that it's commutative, also show that it's not commutative. In case you're asked a question where it's not commutative, you must be able to come out it's not commutative or it's commutative. Thank you. I hope you enjoyed. Please share with your friends.